Good morning to one and all present. I am going to present about the epsilon NFA. So how the epsilon NFA is going to transfer to DFA. So epsilon NFA means with epsilon transition. So for example, construct an epsilon NFA for a regular expression. So the regular expression given is a divided by b the whole asterisk ABB and convert it to your DFA. First we want to draw the transition diagram for the epsilon NFA. So for epsilon NFA, initially it will be started with the initial state Q0 and then the final state will be represented with a double circle. So here for A divided by B. So for A divided by B, this is the transition diagram, and A divided by b whole asterisk, it is represented as a epsilon representation, and then a divided by b whole asterisk followed by a b b. So from q6 to q7 it's a, q7 to q8 it's b, q8 to q9 it's b. So this is the transition diagram for a divided by b the whole asterisk a b b. Okay, first we want to find the from the initial state we want to find a epsilon transition. So epsilon transition of q0. So if epsilon transition of q0 means you will be initially adding the initial state with wherever it goes for the epsilon moves. So here in this diagram for epsilon closure of q0, initially it will be started from q0 and then it goes to q1, it goes to q2 and q3. From where we are getting this epsilon moves is then from q6. For epsilon closure of q0 will be representing as q0, q1, q2, q3 and q6. This is represented as a new state that is named as capital A. Okay, again we will be calculating the epsilon closure for each state. The epsilon closure for q1. So wherever the q1 is having the epsilon moves, we will be represented for epsilon closure of q1. So initial state of epsilon closure is q1, and where it goes is q1. For epsilon it goes to q2, and for epsilon it goes to q3. So that will be represented as a set. Okay, next epsilon closure of q2. So for epsilon closure of q2, for q2 there is no epsilon transition, just we will be writing it as an initial state as q2. So epsilon closure of q2 is q2, then epsilon closure of q3. Epsilon closure of q3 is also q3, there is no transition of epsilon transition from q3. Then epsilon closure of q4. So epsilon closure of q4 means you will be including q4, and then from q4 it goes to q6, and from q6 it goes to q1, from q1 to q2 and q1 to q3. So this will be represented in the epsilon transition of q4. Next epsilon transition of q5. So epsilon transition of q5 is represented with the initial state as q5. From q5 it goes to q6, from q6 it goes to q1, from q1 to q2, q1 to q3. These are the epsilon closure of q5. Epsilon closure of q6. So initial state is q6, from q6 it goes to q1, and from q1 it goes to the state q2 and q3. So that is represented in the epsilon closure of q6. Next epsilon closure of q7. So epsilon closure of q7 is q7 itself, there is no epsilon move on q's transition, and for epsilon closure of q8 there is no transition, so it is represented as q8. Epsilon closure of q9 means it is represented as q9. So these are the initial representation. First we will be considering the new state capital A. For that we will be applying, we will be providing the input terminal A and B. Yeah, so applying the input symbol A and B on the new state capital A. So what are the things that is based on the new state capital A is q0, q1, q2, q3 and q6. So if it is A, it goes to epsilon closure of q0 comma A union epsilon closure of q1 comma A union epsilon closure of q2 comma A union del of q3 comma A union del of q6 comma A. So here you will be calculating a del function. So if it is A, whether it moves. So in this transition diagram we will be seeing that if it is A means, okay, so initially from q2 to q4 you will be having the A transition, and from q6 to q7 you will be having your A transition. So here q4 and q7 will be represented. Okay, then epsilon closure of this q4 and q7 will be calculated. So epsilon closure of q4 and q7 means wherever the epsilon moves. Okay, so here epsilon closure of q4 and q7 is represented as. So if it is q4 means it goes to q6, and q7 there is no epsilon it's Q7 itself, Q4, Q6, Q1, Q2, Q3 and Q7. This is the epsilon transition for Q4 and so this is represented as another new state. Then we will be calculating the another input symbol for B. So epsilon, that is a del of A comma B, which can be represented as the B transition. In this transition diagram, the B transition, it goes to from Q3 it goes to Q5, and from Q7 it goes to Q8. Here we are calculating it only for Q5. So it is represented as here we are calculating it for Q5. So it is represented as Q5, Q6, Q1, Q2 and Q3. So this is represented as another new state. It is named as C. This is for the new state A. Again we are going to calculate the applying the input symbol for B for the new state. Okay, so here while applying it for B, so del of B comma A. So del of B comma A, if there is a transition means that is only the possibilities where it can move is. So there is a possibility if it is A, it goes to Q4, and if it is A, it goes to Q7. This is the two possibility that is provided by the input symbol A. So Q4 and Q7. So del of B comma small, that is the terminal B, which is represented as here for B transition where it goes up. For B transition, here there is a possibility that is Q5, Q8 and Q9. So here what is the thing that is placed is Q5 and Q8, which can be represented for the del of A comma, that is B comma B. Okay, then we will be calculating the epsilon closure of Q5 and Q8. So for this Q5 and Q8, we will be calculating, that is be having the epsilon moves. So Q5, Q8, Q6, Q1, Q2 and Q3. This is represented as the another new state that is named as D. Again, we are going to calculate the input symbol A and B on the new state C. So for C, del of C comma A. So del of C comma A means for A transition it goes to Q4 and Q7, and for B transition it goes to Q5. So this is already an existing state. It is not a new state, so it is named as B. Q5 is also an existing state. It is named as C. Again, we are going to apply the input A and B on a new state D. So D is equal to Q1, Q2, Q3, Q5, Q6 and Q8. So in this new state, we are going to apply the input symbol, that is the terminal A and B. So del of D comma A. So here if it is A, it goes to Q4 and Q7, and if it is B, it goes to Q5 and Q9. So based on your D's states, then we are going to calculate the epsilon closure of Q5 and Q9. So Q5 and Q9, the epsilon moves can be represented like this. We can arrange it in an order Q1, Q2, Q3, Q5, Q6 and Q9, which is also having the same transition as it is like E state. So that is a no new state has been created. It is also an already existing state. So here again for the E state, we are going to calculate the input symbol A and B, that is del of E comma A, del of E comma B. So here E comma A means you will be having Q4 and Q7, which is already an existing state, which is named as B, and then del of E comma B, which is also represented an existing state, which is named as C. After calculating this input symbol for all the new state, we want to draw the transition diagram. Based on from your transition diagram, you want to draw your transition table. So how we will draw the transition table is the first initial state will be represented as an arrow, and then the final state will be represented as an asterisk, or otherwise you can represent the final state as by representing a single circle. So for the input symbol A and for B, where it goes up. Okay, so initially the new state is capital A. If the input symbol is A and B, where it goes is it goes to, if it is A, it goes to B. If it is B, it goes to C. So that will be represented on your transition table. Again for the new input symbol B, where it goes for A and B is it goes to, if it is B, it goes to, so here del of B comma A, it goes to D, and then here it was having the same state, it's represented as a B. Okay, so here in this transition table for B it goes to B and D, and for new state C it goes to B and C, and for new state D it goes to B and E, and for the new state E it goes to B and C. So this is the transition table. Here there is no epsilon moves has been placed. Then we want to draw the transition diagram from this given transition table. Okay, so here we have been removed our epsilon moves. This will be converted to a DFA. From this we want to draw the transition diagram. So initial state is represented with the arrow marks, and then the final state will be represented with a double circle. So double circle, the final state is E, initial state is A. From A, if it is the input symbol is A, it goes to B, and the input symbol is B, it goes to C. And then for the B new state, for the input symbol A, it goes to B itself. For the input symbol B, it goes to D. And for the new state C, if it is A, it goes to B. If it is C, it goes to C itself. It is represented as a loop. Then for D, it goes to, if it is A, it goes to B, and if it is B, it goes to E. And for the new state E, if it is A, it goes to B, and then if it is B, it goes to C. This is how we will be removing our epsilon moves from NFA to DFA. Thank you, students.